And good day to all of you. We will proceed with the lecture, and at this time around we'll focus on reaction forces. Okay, given an example so that we can discuss and we do together, right? So the figure shows a 900 kg car on a bridge of mass 2000 kg. So you calculate the reaction forces at point A and point B. Okay, so how do you do this? So first thing first, I convert this mass to weight. Okay, W equals to mg. So you will get this one is let us see, 900 times 9.81, and then this one is 2000 times 9.81, right? So you will get 19620. Okay, so for the first condition you apply, okay, all the forces in vertical component is 0, so that makes sigma Fy vertical or either y component, so we get 0. And we look at the forces acting, so Ra is positive, so Ra upward positive, and then plus the Rb is also positive, and then you minus the 8829 Newton, and you minus 19620 Newton equals to 0. So you will get Ra plus Rb minus 28449 equals to 0. So this is the first equation. Since you have two unknowns, so you need to establish another equation so that you can solve the problem. Alright, so you need to apply the second condition. Okay, the second condition, summation of torque. At this time around, I take P as the point, so equals to minus Ra. Okay, so taking into consideration that counterclockwise is positive, then the Ra here is clockwise, so it's minus. So minus Ra times the lever arm, so lever arm of that particular point from B to that particular Ra is D, so D. Okay, and you plus with the 8829 because it's counterclockwise, plus, so 8829 times 8829, the distance is from this point to this point, so D minus D over 4, you will get 3 over 4 D, and then you plus with 19620, and the distance 19620 from B is half D. Okay, so half D, so you will get equals to 0. So you simplify the equation. Okay, so you will get the Ra. You can cancel off the D. Okay, so Ra plus 8829 times 3 over 4 times 3 divided by 4, get 6621.75. Okay, plus 19620 times half, you get 9810 equals to 0. So you will get Ra, okay, sorry, Ra equals to 16432 Newton. Then you substitute this value, okay, this value to the first equation. So RA plus RB minus 28449, so 0. So that makes RB equals to 28449 minus 16432. You will get 12017 Newton. Okay, so you get the answer for RB. So the RA is 16432 Newton and the RB is 12017 Newton. Okay, so we move on to the example 6 here. All right, a 50 Newton weight is held in a person's hand with the forearm. A 50 Newton weight is held in a person's hand with the forearm horizontal as shown in the figure. The biceps muscle is attached 0.03 meter from the joint and the weight is 0.35 meter from the joint. Find the upward force exerted by the biceps on the forearm, the ulna, F, and the downward force exerted by the humerus on the forearm, R, acting at the joint. Neglect the weight of the forearm. So how do we do this? Okay, so the same thing. Okay, we just use the first condition. Okay, first condition, we look at the forces related. All right, so all in y direction, right? So the sigma Fy equals to F, okay, plus, and then minus the R, this one, and minus 50, minus 50 will get equals to 0. Okay, so this is the first equation. Since you have two unknowns, so you need to establish another equation, so we use the second condition. So the second condition states that summation of torque at any point will be equals to 0. So we take the point O as the point. So sigma torque at point O will be equals to 0. Right? So we can calculate. So the F here, okay, is positive times 0.03 meter, and then you minus the R, minus 50, okay, times 0.350, you will get 0. Okay, so at R is 0 because the lever arm is of course 0. So now you get to find the F. So the F is now 50, 0.350 divided by 0.03. So you will get 50 times 0.350 divided by 0.03. You get around 583 Newton. Okay, so again you can substitute this value into the first equation, so you will get the R. Alright, so from the equation, R equals to F minus 50. So F is 583 minus 50, you will get 533. Okay, so Very simple, and I think you guys can do it. Let us move to another example. Okay, walking a horizontal beam. Okay, a uniform horizontal 300 Newton beam 5 meter long is attached to a wall by a pin connection that allows the beam to rotate. Okay, its far end is supported by a cable that makes an angle of 53 degrees with the horizontal. If a 600 Newton person stands 1.5 meter from the wall, find the tension in the cable and the force exerted by the wall on the beam R. Okay, so how do you do this? Okay, so from the question we know that this is the R, this one is the tension, and this one is 600 Newton and 300 Newton. 600 Newton is due to that person, okay, and 300 Newton is the beam itself. Okay, so you sketch the free body diagram, okay, and then you resolve the forces T, this one, and R into their horizontal and vertical components. So you look at this one. So the hinge here, okay, the R can be in terms of Y component and X component. This one. Same goes with the tension. This one and this one. Okay, T sine 53 degree and T cos 53 degree. Okay, so now we can just actually follow the first condition. So the first condition states that summation of forces at X will be equals to 0. So we look at the X component first. So the X component is Rx and T cos 53. Right? So the Rx, okay, and then we'll minus the T cos 53 degree. Okay, so you will get 0. What about the Y component? Okay, Y component. So the Y component equals to the Ry, okay, also plus the T sine 53, and what else? You have 600 Newton and 300 Newton. So minus 600 Newton and then minus 300 Newton. You get equals to 0. So this is the first equation. This is second equation. So if you confuse, okay, the Rx is actually equals to this part. Rx, is equals to this part. That's why Rx is actually equals to T cos 53. So we bring to the left side. So it's minus T cos 53 equals to 0. Okay, and we get the second equation here for Fy, and we can apply for the second condition, okay, to solve this problem. So this is first condition, this one is second condition. So you take at any point. So here we take as point O. So the sum of torques about any axis must be 0. So I choose at pivot O. So sigma torque at O equals to 0. So we look at the forces one by one, right? So for torque, so the T sine 53, this one, T sine 53 degree times the distance 5. Okay, up to this point it's 5 meter. Okay, so 5, and then minus the 300. Okay, minus 300 Newton times, and the lever arm is 2.5. Okay, you minus the 600 times 1.5. The distance here is 1.5. Okay, from this point to this point. All right, then you will get equals to 0. Okay, so you rearrange the equation and you calculate the T. You will get okay, so T sine 53 times 5, so 300 times 2.5, 5, 750 plus 600 times 1.5, get 900. Sine 53 times 5, 4750 plus 900 divided by 4. So you will get 413 Newton. Okay, 300 times 2.5 plus 600 times 5, 650 divide by 5 divide by 3. You get around 413. So divide by sine 53 degree 5. So you will get around 413 Newton. Okay. Then you can substitute T into 1. Okay, into this first equation. So you will get the Rx. Okay, you get Rx equals to, after you substitute, you will get 249 Newton. And then when you substitute to the second one, you will get Ry equals to 570 Newton. Okay, so that's all for today, and I hope you guys can try and solve the problems together with your friends, and you discuss among you guys. I will see you guys in the next lecture. Thank you very much. Assalamualaikum.